Well, hey everyone, welcome to the 5 strategies to build a bridge to grade level math. My name is Chrissy Allison. I am the founder of Mindful Math Coach. And in this video, I'm going to walk you through 5 of my favorite strategies to increase access to grade level math. And before I forget, if you want to get your own copy of these strategies, you can go to mindfulmathcoach.com/bundle, where I've included these and some additional strategies in a downloadable PDF for you. All right, so strategy number 1 is notice and wonder, which you may already be familiar with. It's become pretty popular these days, and it's actually embedded in a lot of the newer curricula that are coming out. Notice and wonder is an instructional routine where you put a problem, a task, or an image on the board, and you simply ask students to answer the question, what do you notice and what do you wonder? You can have them share with a partner and then as a whole class, or just call on students right off the bat. So pretty simple to implement, but highly, highly engaging and gives you a great window into what students are thinking about and what their prior knowledge is. And it also gives students a chance to hear from other students about something that maybe they didn't know already. Here's an example from the illustrative mathematics curriculum, grade 8. So you can see here, there's just 2 graphs and students are just asked, what do you notice and what do you wonder? They're not solving anything. They're not giving any specific answer. They're just thinking about it and sharing what comes to mind. And here is a high school example. I love this one. We've got the hangers, and this is a lead-in to a lesson about solving equations and, what does the equal sign mean and keeping equations balanced. So really great warm-up activity. These only take a few minutes. And again, there's, no preparation really, just very simple to implement, but highly, highly effective. Another thing I like to do is add notice and wonder into a problem that doesn't already have it. If I'm looking at a problem thinking, my students might have trouble just jumping into this one. They might not know exactly where to start, or it might even just be intimidating to them. And sometimes, you get those deer in the headlights looks from students, or students who just, they don't know where to start, so they don't do anything. So if you're looking at a problem and thinking this might be the case, have notice and wonder in your back pocket. So that's what I would do with this problem. Instead of asking them to graph it right away, I might just show them the equation or just show them the graph and ask them to, notice and wonder for a few minutes before jumping into actually graph the equation. With visual models, we're really just making the math visible. So you're taking mathematical concepts and you're putting something on the board, projecting something in order to help students make sense of the math. So a few ways to do this are tape diagrams, simple pictures or drawings, and another one that's become quite popular is area models, especially in the elementary grades where students are learning about multiplication and division. We see a lot of area models. So here's a problem from the Engage New York curriculum where a visual model might be helpful. You can take a minute, read the problem, and think about how you might solve it. Now, if your middle schoolers are anything like my middle schoolers were, when they see a problem with a lot of different numbers and a lot of different quantities, sometimes they had the habit of just taking numbers and starting to add them, multiply them, sort of do different operations haphazardly or at random. So what a visual model could help them do is actually really make sense of the quantities and the relationships between them in order to think through and reason through what actually would make sense in terms of operations and in what order to perform them. So I love to introduce students to visual models that they may be able to use then to solve in the future. So here is how this could look for this problem. So you can see here how this visual model could help students really make sense of what's going on here. We have Tom and Sally and their the relationship between their money at the beginning, which is that Tom has 75% of what Sally has. And then after Sally spends some money, then Tom has more. And that's represented with the bars at the bottom. And through this, you can see that after Sally spent $120, she now has, 2 less bars than she had before, so to speak. And so each one of those is $60, right? You take that 120 and say, oh, that's divided up between those 2 bars. And so now I know that each one is $60. And from there, you can answer the question of how much did each person have at the beginning. So the next strategy is called 2 solutions. And I coined this term because I see so often in a lot of lessons where we're using tasks and having discussions and re-engaging students after they've taken an assessment, this strategy of using students' work as a starting point for discussion. So I've just kind of simplified it here by saying, pick 2 student solutions, put them on the board or project them or share them and have a discussion about them. I did just that when I worked with a teacher who was looking at the assessment. You can see here, students were writing an equation for different lines, and some of them got them right, some of them got them wrong. You can see some of the examples here in the middle. Y equals 4, X equals 4, 4, negative 4. And they were trying to write the equation for line L, which is the purple line that you see going completely horizontal. So what we did is we just picked 2 of the answers, put them back in front of students and asked them to think about and discuss which one is correct and how do you know? And this helps students get clearer about how do you write the equation for a horizontal line. Now, another way to do this is for you to create 2 potential solutions and put those in front of students before they actually solve, the rest of the problem. So you can see here a problem that I found. It says Tyler was at the amusement park. He walked at a steady pace from the ticket booth to the bumper cars. Question 1 says, what do the coordinates of the point on the graph tell us about the situation? Now, I was thinking that sometimes questions like this that are so open-ended and ask students to describe something, sometimes that can be a little bit tough as a starting point. So if you think that might be the case, here's an idea. Pull out that first question and then give students 2 ideas. So you could say, what do the coordinates of the point tell us about the situation? A, that after 40 seconds, Tyler had walked 50 meters from the ticket booth, or B, after 50 seconds, Tyler had walked 40 meters from the ticket booth. And let them have a conversation where, they would articulate how they know that the answer is A. Now, it might seem obvious to you, and they may even know right away that it's A, but what you're doing is you're helping to give them the language and you're sort of modeling how you would describe what this point represents. And that's going to help them when they answer other questions about what other points mean. All right, strategy number 4 is to narrow the focus. Now, when you narrow the focus, you really want to get clear on the learning goal of the lesson so that you don't end up prioritizing tasks and problems that don't align, but instead that you select the ones that really get at the heart of the lesson and are going to allow students to achieve that learning goal, even though you're not covering every single problem. Now, I have a few examples here, and I have linked these in the slide deck for you, and so you can pull them up and take a look. But I worked with a teacher and her math coach to adapt a lesson in order to make it more accessible for the entire class. And so you can see the original Engage New York lesson plan, and then the modifications or the adaptations that the teacher made following those 3 steps. Here are some notes from that meeting. And essentially what we did was we focused on the learning goal and got really clear on what we were trying to accomplish with the students and what we wanted them to understand, which is what is an expression, how are they structured, to be able to state whether or not 2 expressions are equivalent, and then to defend their answer or justify using an algebraic expression and using algebra, basically. Then we spent some time talking about the highest leverage question. And we decided that question 3 from the teacher's adapted lesson plan was really, fit squarely with this lesson goal. And so if we could spend more time in the lesson on that one, give students a chance to engage with it, discuss it, share different solutions, and talk about it, that would really help move them towards the learning goal. All right, strategy 5 is to remove barriers. Now, there could be a lot of different things that would get in the way of students being able to have entry into the problem and to kind of get confused by the lesson before it even starts. So one thing to keep in mind is that we want to remove unnecessary barriers, but we don't want to lower or change the rigor. We don't want to strip the thinking from the task. So here are some potential barriers. Sometimes the context or the scenario is something students are unfamiliar with. In that case, we can explain the context, we can build some background knowledge, or sometimes just change the scenario. Language and vocabulary, right? That can get in the way if students are reading it and they don't know what all the words mean. Unfriendly numbers. Sometimes, when I taught middle school, I just knew if there was a fraction or a decimal in the problem, sometimes integers and negatives. Some students would be a little intimidated by that and get some anxiety. And so just keeping that in mind and thinking about how we can lower their anxiety there, and when it does or doesn't make sense to maybe adapt the numbers or allow them to use a calculator. And then finally, visual overwhelm. So simply having too much text on the page, too many problems on the page, sometimes can just, again, be kind of intimidating and get in the way from students being willing to jump in and just get started. All right, so here's a problem from illustrative mathematics, grade 7. And you can see here that there's an equation with Fahrenheit and Celsius. And I was thinking that potentially the context of this problem might be something that all students are not familiar with. And additionally, the fact that there is a fraction in there. So one idea would be to just build a little background knowledge about these two ways of measuring temperature. So show a map here, show a thermometer, and have a little bit of conversation about the fact that there's different ways to describe what the temperature is, and we have these two different systems. And hey, fun fact, did you know that the United States is one of very few countries who still use Fahrenheit? Another thing you can do is switch the order of the numbers. So instead of starting with 20 and then going to 4, how about starting with 4? It's a lower number. And sometimes, that can help students just feel like it's more approachable, and then move on to 20 once they're like, oh, all I'm really doing is substituting 20 in where the C is and, evaluating that expression. If you think that 4 is going to get in the way, maybe they don't really have calculators to use, or they're not proficient yet with multiplying a whole number and a fraction, and you don't have time to get into that, you could substitute the 4 for a 5, and it really wouldn't make a difference in this problem. I also changed the last number to a 100 for the same reason, just because this problem is really about filling out the chart and then talking about, is this a proportional relationship? And I wouldn't want, as the teacher, I wouldn't want filling out the chart to take so much time that we don't even get to spend time discussing that really important question that gets at the heart of the lesson. Now, how do I know that's the heart of the lesson? Well, I looked at the standards. And so that's a tip. When you're planning your lesson, if you're using a curriculum, look at what they say the learning goal is. Read the lesson goal, read the objective. There's lots of different titles for that, different ways people describe them, but it's essentially the same thing. What's the purpose of the lesson? What's the goal of the lesson? But then also look at the standards so that you make sure that when you are adapting, you're not changing the rigor, right? You're not making something that was meant to be conceptual, procedural, or something that was meant to be problem solving and application and, giving them the step-by-step. And also that you're not, unintentionally making it align to a different grade level, right? So if you take all the fractions out, then that's not really a 7th grade problem anymore, right? We see here with 7 RPA1, we're meant to be interacting with fractions here. So we don't want to only do whole numbers. All right, here's another example where I thought visual overwhelm could potentially be a factor. And so one idea, pull out the first piece, add a visual, and just break it into parts. Don't do it for them, don't walk them through it, but just show them one piece at a time so that they can kind of dip their toe in and not have to look at it all at once and be like, this is so much. And then finally, again, paying attention to the vocabulary here. So maybe asking students, what does increased mean? What does elevation mean? Can anyone share with us, or potentially, draw something on this diagram here to illustrate, okay, what we mean by elevation is, how high on the mountain we are, how high up, how high down we are. All right, so those are the 5 strategies. And now it is time for you to adapt your own lesson. And I think it'll be helpful to approach it by following this process here. So first, articulating the learning goal, then anticipating, where do I think students might get stuck? Where are 1 or 2 places where I think they're going to need a little bit more of an on-ramp, a little bit of that bridge before they can just jump in? And then use some of these strategies or other strategies that you're aware of to adapt the lesson. Now, I like to think of the adaptations in 2 categories, either adding or subtracting. So what could you add? Well, we've talked about some things today, right? You could add an instructional routine like notice and wonder, or 2 solutions, or which one doesn't belong. You could add a math language routine. Go ahead and Google those if you're not familiar. I didn't include them in this presentation, but those are really great to increase accessibility for English language learners. You can also add in visual models or concrete manipulatives. And the use of calculators can be helpful too, depending on the standard. All right, so what can you subtract or remove? Well, to narrow the focus, narrow the scope, you can remove some problems or tasks. You might remove a part of a problem. If it has, 6 parts, maybe you zero in on 2 or 3 of the most important ones that really align to that learning goal. And you can also remove unnecessary barriers, but make sure that you don't lower the rigor, as we've already talked about. Okay, so now it's your turn. With your team, take some time to plan an upcoming lesson using this 3-step process to increase access for all of your students. And if you want, you can let me know how it goes.